Welcome everyone. So today we are going to learn about coupling scheme, especially LS coupling and JJ coupling. In atomic physics, coupling refers to the interaction between different parts of an atom. The interaction between the orbital and spin angular momentum of electron known as spin orbit coupling, and these coupling scheme are crucial to understand atomic structure and spectra. So now two types of coupling scheme is there. One is LS coupling and second is JJ coupling. So first we're going to talk about LS coupling. So first we are going to consider LS coupling, and in LS coupling all the orbital angular momenta vectors Li of various electrons combine to form a resultant L. Independently, all their spin angular momentum vectors Si, they combine to form a resultant S, and this resultant L and S then combine to form a resultant total angular momentum J of the atom. Now we can summarize this scheme in this way, where L is the sum of individual Li, that is L1 plus L2 plus L3, all those individual values of L, and S is the sum of individual Si values, that is S equals to S1 plus S2 plus S3, sum of all individual Si values, and this resultant L and S, they form the J value, that means J equals to L plus S. If Li and Si be orbital and spin quantum numbers of individual electron, then Li equals to root over Li into Li plus 1 h cut, and Si is root over Si plus 1 h cut. Here Li and Si are the individual spin and orbital quantum numbers. So for two electron system, L can take values L1 plus L2, L1 plus L2 minus 1 up to L1 minus L2, and S can take values S1 plus S2, S1 plus S2 minus 1 up to S1 minus S2, and the possible J values are L plus S minus 1 up to L minus S when L is greater than S, and the J values when S is greater than L will be S plus L minus 1 up to S minus L when S is greater than L. Okay, so let us consider the LS coupling of 3p electron with a 4d electron. For 3p electron, the value of L1 is 1 because it is p, and for 4d electron the value of L2 is 2, and the value of S1 is half and value of S2 is half. The possible values of L is 3, that is 1 plus 2, that is 3, 3, 2, and 2 minus 1, that is 1. So there are three possible values of L, 3, 2, and 1. And the possible values of S is 1 and 0, because 1 by 2 plus 1 by 2, that is half and 0. And the possible values of J is L plus S up to L minus S. So here S has two values 1 and 0, but L has three different values 3, 2, 1. Now we will consider their states. Now depending on the values of S and L, we can write the spectral notation terms for different J values. So first we will consider the value of S when S equals to 1, and we will consider three different values of L, which is 3, 2, 1. So when S equals to 1, L equals to 3, the values of J, that is L plus S into L up to L minus S, that is 4, 3, 2. We can write the spectral notation in this form, considering the general expression which is 2S plus 1 Lj, putting the values of S and L and the J values here, we can get these terms, that is 3F4, 3F3 and 3F2. When S equals to 1 and L equals to 2, the values of J will be 3, 2, 1, and their corresponding states will be 3D3, 3D2, 3D1. And when the value of L is 1 and when the value of S is 1, then the J values will be 2, 1, 0, and their corresponding states can be written in this way: 3P2, 3P1, 3P0. in your previous example we have seen that s has two different values, 1 and 0. So we're gonna repeat this thing for s equals to 0 value also. So when s equals to 0, the values of L 3, 2, 1. So for s equals to 0 and L equals to 3, the J value is 3 and its corresponding spectral term is 1f3. And when s equals to 0 and L equals to 2, J value is 2 and the term is 1d1. Similarly, for s equals to 0, when L equals to 1, the value of J is 1 and the corresponding spectral term is 1p1. So this is the example for LS coupling. So now we will consider JJ coupling. This type of coupling exists in heavy atoms, and the orbital and spin angular momentum of each electron in the atom are added to obtain the resultant angular momentum J. Ji is equals to Li plus Si, and the total angular momentum J of the atom is summation Ji, that is J equals to J1 plus J2 plus J3. That means sum of all Ji values, individual Ji values, is the total angular momentum value. So now we will consider an example for JJ coupling, and let us consider the JJ coupling of a NP electron with ND electron. So for P electron, the value of L1 is 1 and the value of S1 equals to half. So J1 can take values 1 plus half, that is 3 by 2, and 1 minus half, that is half. And for D electron, the value of L2 is 2, since it's D, so value of L2 is 2 and the value of S2 is half, and J2 can take values 2 plus half, that is 5 by 2 and 3 by 2. So the 4JJ combination gives the following J values. Now here we have 4 values of J, that is 3 by 2, 1 by 2, 5 by 2 and 3 by 2. These 4 different values of J can give us this combination, can give us the following values of J. If we consider J1 equals to half and J2 equals to 3 by 2, the value of J is 2, 1. And the value of, if we consider the value of J1 which is equals to half and J2 equals to 5 by 2, then the value of J will be half plus 5 by 2, 3 and 2. And the value of J1, if we consider 3 by 2 and J2 3 by 2, the value of J is 3, 2, 1, 0. Similarly, in case of J1 equals to 3 by 2 and J2 equals to 5 by 2, the values of J is 4, 3, 2, 1. Now we will write their corresponding states. Now we can write the 4 states in this way, considering the values of J1 and J2. So for J1 equals to half, J2 equals to 3 by 2, the values of J is 2, 1. So we can write this state, the corresponding state, in this way, that is half 3 by 2, and the value, we can put the values of J here. Similarly, for J1 equals to half and J2 equals to 5 by 2, we have the values of J as 3 and 2, and we can write their corresponding state in this way. We can put the value of J1 here and J2 here, and the values of their corresponding J in this way. And similarly, for J1 equals to 3 by 2 and J2 equals to 3 by 2, we get the J values as 3, 2, 1, 0. And if we put those J values here, we will get this term in this way. And considering the value of J1 equals to 3 by 2, J2 equals to 5 by 2, we can write their corresponding state in this way, that is 3 by 2, 5 by 2, and we can put the J values here as 4, 3, 2, 1. Okay, so I think now you have a clear idea about LS coupling and JJ coupling, and on our next class we will talk about Landau factor, and we gonna discuss some example also. Thank you everyone.